So here is the lucky parabola, that equation that I just gave you. I told them in words to write a parabola that's been stretched with a vertical stretch of 7, and it moves 7 to the right and up 7. 7, 7, 7 is a typical like winning thing at the casino. 7 parentheses x minus 7 squared. Did you forget the squared? Because otherwise it's not a parabola unless that's squared. And then plus 7. Raise your hand if you had that one right. Awesome. Now, what if I give you a picture of a parabola and you're trying to decide what its equation is? Well, you'd want to know some stuff, right? You'd want to know what that point is. That's 4, 1. And this is important. You'd have to know whether or not, when you went over 1 and up 1, whether there was a dot there. And there is in this case. That tells you it has not been stretched. Do you get if you go over 1 and up 1 and there's no dot there? Like if this parabola was like really loosey-goosey like this, then that hasn't been moved. That's not a normal parabola. That one's been stretched. All right, so back to this parabola. It's got a vertex right there, 4, 1. Can you write the equation for it? This one isn't even that bad. It hasn't even been reflected. All right, row 1 and 2, row 3 and 4, and the rest of you guys know who I usually pair you with. Talk to that person next to you and see if you got the same thing. Up 1, correct. All right. You guys agree with that one? All right. Now can you tell me 3 other points that would be on it? Because making points on an XY chart, huge on the next test. Like seriously, I can say this with confidence. If you can't find points on an equation like that, you will not pass this next test. It happens on so many problems. Such a fundamental skill. Gotta practice those. So which points should you pick? Well, you can pick anything you want. But I did say starting with 4 in a problem like this would be smart. Is it required? No. But see, if I put in 0, I'm going to end up with 17. Do you think 0, 17 is going to even graph? 0, 17 is going to go off your graph. It's kind of a useless point. So 4, much smarter to start with. And if 4 works, Mr. Savage, what's another logical number to put in? 5, maybe 3, yep. In fact, I can look at this equation and I can pull out 4, 1, just looking at it. Do you know that? That's called the vertex. I know vertex form, so I know that that 4, 1 is important. So 4 must go with 1. See how that comes from there? And that tells me that. Start with a vertex and then go near it and you won't go wrong. Then when you put in a 3, 3 goes here. You got -1, but you square it. That makes it +1. Add another 1, and you get 2. You put in the 5, and 5 minus 4 is 1, and it's going to come out exactly the same because of the squaring. So there you go. And if I actually looked at 5, 2, that would be right there. It makes sense. And 3, 2, over 3 and up 2, that would be right there. So, I hope this is coming together for you. Now, here's the weird exceptions. Kids trying to figure out if 1 over, wait, one thing at a time. 1 over x had this happen to it, what's going to happen to the function? Would you agree you have to put a 2 on the inside? Okay. Now, where is the inside? So, if I put a 2 on the inside of this function, should I put it on the top or on the bottom? All right. Now, why? Let's talk about why it would be on the bottom. Let's let me just ask you this. If I said I wanted to do a vertical stretch of 2, would you agree I have done a vertical stretch of 2 now? Was that a vertical stretch of 2? Then do you get, if I actually multiply that out, the 2 would end up on the top? That's going to mess with some people's heads. They're like, you just put it inside. No, I didn't. Might seem like it's on the inside now. But that's a vertical stretch of 2. And because it's like a 2 over 1, that 2 would end up going on the top. Mathematically, this and this are identical. This one's easier to see that is a vertical stretch. But that's a vertical stretch too. So what if I want to do something on the inside? You'd have to go inside with the x. Like that just moved 3 to the right. You have to put it in there with the x. Okay, so the inside on a 1 over x function is the stuff by the x. That's actually on the outside, because you could think of it as it used to be a 2 on the outside that multiplied into it. Why doesn't it multiply on the bottom? Because it's 2 over 1. Okay, this is the weird exception time. So if these are confusing you, it's understandable. They're really confusing. That's why I'm bringing them up. Okay, here's another weird exception. Only one of these actually moves to the right 8. And a lot of kids put one of these answers and they think that either one of them would be fine. They think, well, I put a 4 on the inside and I times it. And I moved it 8 to the right. I have a minus 8. How come I'm being marked wrong here? Only one of these is properly doing right 8. Is it A? Is it B? Which one is properly doing right 8? Talk to the kid next to you and see which one you think. How many of you think it's A? Raise your hand if you think it's A. How many think it's B? All right, you're all wrong. I'm not kidding. This one is the one that moves right 8. That's why I'm bringing it up. That's why I'm saying it's complicated and tricky. Now, how can I prove it to you? I know some of you are going to be like, no, you're doing it wrong, server. Or maybe some of you just trust me because I'm the teacher. But how can I prove it to you? If you graphed this parabola, would you agree this is a parabola? Would you agree that if you actually looked at the picture and you saw what the picture looked like, you'd be able to tell which one of them actually moved right 8? I'm not going to be able to record this part because I'm not going to be able to put that into the recording, but I can show you. So hold on, we'll pause the recording for a second. And showed them, and this one right here, when we graphed it, it did not move 8 to the right. It only moved 2 to the right. This one, when we graphed it, the parabola was sitting over here, moved over 8 spots to the right. So that's the way you should do those. Okay, you want to know what I think is the hardest kind of question on the whole test? And it's not tomorrow, it's the next day. So you got another whole day of review. Here's the hardest kind of question. You got to look at something that's been moved and stretched and try to figure out what its equation is. Well, first of all, you got to know that that's a parabola. So you'd start with the parent function is just x squared, but then a lot of things have happened to it. And I'd have to tell you some stuff like the vertex, which is at 7, 1. Nope, 2. Sorry, 7, 2. And then this point, which is at 6 comma 0. That is enough info that you'd be able to tell exactly how much it got stretched, and you'd be able to tell all the changes to it. So you can write me the equation for this. There is a reflection in it. All right, do your best. Write what you think the right answer for this is. And then compare it with the kid next to you, and don't be surprised if yours looks different. And you'll have to argue it out. See which of you is right. Well, I know it moved to the right 7, so there's got to be a minus 7 on the inside. Do you guys agree with the minus 7 on the inside? Yeah. Do you agree it's been moved up 2 and therefore there's a plus 2 on the outside? It's also been flipped vertically, up and down kind of flip. Normal parabola looks like that. So it's been flipped vertically, so there's a negative there. How many of you are right so far? Okay, cool. What's the last melon? The last thing. It's stretched. How do you know it's stretched? Well, first off, you should be thinking to yourself, a normal one goes over 1 and up 1. That's the spot I told you to look for. Is every graph goes through the point over 1 and up 1. I'll prove it one last time. Look, the V shape, it goes through 1, 1. The square root, it goes through 1, 1. The parabola, it goes through 1, 1. All of them, from the vertex, go over 1 and up 1. But this one doesn't. So that's how you can tell, well, it's been messed with. How about over 1 and down 1? Well, that's not going down far enough. Because why? Because I can prove it. If I go over 1, that's back to 6. You know, I'm at 7 right here. And this is back to the 6. That's how I can prove it's moved over 1 and down 2, because it was at 2 and now it's at 0. Therefore, it's a vertical stretch of 2 right there. Who had that one right? All right. Now, that, to me, is one of the hardest things. You look at this shape and you're like, has this been stretched or not? Well, kind of looks like maybe it has been. You got to go over 1 and up 1, and if there's nothing there, then you go, oh, it looks like I had to move up 2. It's probably a vertical stretch of 2. Or it could be that it's stretched wider than normal, and you know it looks like ridiculously wide, but what do you look for? You look for over 1 and up 1, and there's nothing there. But if you go over 2, then there's something there. That one's been horizontally stretched, twice as wide. All right, that's one of the toughest things. And then the only other thing that I'm a little scared about is there's one set of problems on the test that look like this, where you got this weird little shape that's like a little box. And let's say that I said this is f of x. If I asked you to graph for me f of 2x, a ton of kids would get things wrong. Make a prediction. What do you think kids do that's a mistake? Like if I told you the kid just did it wrong, what would you guess they did wrong? Yes?
They squeezed it instead of stretched it.
All right. Except I think you just did it backwards. So let's talk about which one is it. It's the squeeze or the stretch thing. Yeah. So this 2 here, what does it feel like you should do? Stretch it. What should you actually do? Shrink it. Horizontally shrunk. And then another set of kids are like, well, then I'll just try to shrink it horizontally. I'll make it smaller so it's like not as big as it used to be. Wrong. Yes, that one is shrunk, but that's not how you shrink them. The way you would shrink them is you would find the original points, and then you would mess with the original points, and you'd see that it got shrunk half as wide as it used to be, but still as tall, and it would look more like that red box right there where the 0, 0 doesn't get moved. So what you do is you make an XY chart and you list all the points that they give you, 0, 0, 2, 2, 2, 5, I think, and I think, no, wait, it's not 2, 5, like 5, 2, sorry. I'm going to give you some parent points. And 7, 0. If I had these parent points right here, and that's supposed to be my black dots that I started with, then does this tell me to multiply all the inside ones by 2? No, because you can't trust it. Instead, it tells me to divide them. No, don't divide them. There's a reason that'll really mess you up later. You have to multiply them by something, a half. And when you would say the directions on this, you would say that this is a horizontal shrink BFO by a factor of 1/2. You see how if you would have said divide by 2 right there, it doesn't make sense? By a factor of divide by 2, that's not a thing. So that's why we don't want to think of this as divide by 2. It's multiply by a half. So I'd take all my x numbers and I'd times them by a half. All right, I just showed you all of the hardest things on the whole test. So if you feel a little lost right this second, that would be normal. If you were completely tracking that, then you probably are in a good place. Now we'll also get in, it's like going to the doctor. Sometimes they give you a little test, like a blood test. I'm going to be going to the doctor this fall. They'll probably run my cholesterol and all these tests. And if there's anything that's like, ooh, that's scary, like your hemoglobin is way off or whatever, that's like, oh, warning sign, I guess I better change. Well, same thing for you. Take out the quiz that I told you to do over the weekend. I'm about to read you the answers. And hopefully, that little test will come in and tell you whether you're okay or not. And then I'm going to pause the video for a second because I want to record into the video which homework problems you can skip. We'll do that last. For right now, you're just taking out your quiz. We're going to grade that. I'm going to pause while we grade that together. So on your homework, I told students that they could, on number 1, all they had to do was problem A and problem C and problem E, which obviously implies skipping the other ones. On number 2, we're supposed to write an equation that does some things. Torsten, give us your best guess on what it is.
I think it's y equals -3 of the square root of x minus 2.
All right, would you just read me the directions again on what it was supposed to do, and I'll check if you did it right.
The graph of y equals squared x is stretched vertically by a factor of 3.
There's your 3.
Reflected over the y-axis.
Reflected, wait, over the y-axis.
Yeah.
Selected over the y-axis is, let me show you, this kind of reflect, and that's a horizontal reflect. And then do you remember me saying something important about this? Parentheses here. How many of you remembered the parentheses there? See how easy that is to forget? Only 4 people remembered the parentheses there. Otherwise, it's not in factored form. And if you can factor it, you should. And if you didn't have the parentheses, then this wouldn't have actually moved to the right too. With the parentheses in there, it will move to the right too. It will have the right kind of reflect. And was there a 3 for a stretch, vertical stretch of 3? Okay, awesome. That's what it should look like. And it would be so easy to forget these parentheses, and it totally changes it. Got to have them in there. It's got to be factored. Okay. Yes?
For like horizontal stretch,
Yep.
could that be a vertical shrink?
Excellent question. If they are telling you to make a horizontal stretch, then you make a horizontal stretch. If you are given a graph, I would agree that, for instance, this one, where it's a stretched parabola, where 1, 1 would have been, like it missed 1, 1, and it went to 1, 2. that you could argue that that is a vertical stretch or a horizontal shrink. So if you're taking an equation from a picture, then you could write it and do it either way. But if you are told you must do a horizontal whatever, then you got to do it on the inside. Get what I'm saying? So you're not wrong. This could be thought of as a vertical stretch or a horizontal shrink. But default to vertical, it's so much easier. Since you have the choice, try to make them vertical stretches. Okay. Now I know there's going to be more questions about the homework. I totally get you want to ask me some stuff. So I want to leave some time for that. Does anybody have a question before I stop the video? All right, that's all I got for the video for today.